All right, today we're talking about a massive shift, a real game changer in how things get made. We're basically moving away from measuring stuff that's already been created to a world where we can actually design the perfect experience right from the start. So let's dive in and see how this all works. So just picture this for a minute. What if you could just completely skip all those endless lab tests? You know, the consumer panels, all that expensive, frustrating trial and error. What if you could just design the perfect product experience right from your computer before you even think about mixing the first ingredient?
Well, that's the promise, right? We're talking about a future where you don't just cross your fingers and hope you get it right. No, you predict it with, pinpoint accuracy. And this isn't some far-off sci-fi concept. This is the new reality, right now, in product development.
Okay, so to really get your head around how big of a deal this actually is, we got to look at how things are done right now. You know, the current industry standard. We'll just call it the old way. And it's all about one thing: measuring stuff that's already been made.
So up until now, the best tools we've had operate at the molecular level. It's something called kinetic analysis. And look, it's useful for sure, but it's fundamentally reactive. All it can really do is answer one question: how fast do things happen in this physical sample that we've already created? That's it. But now there's a new way, and it's a huge leap forward. It's a shift that takes us from just reacting to actually predicting. We're moving from the molecular to the quantum. And this slide right here, this really nails the core difference. See, molecular analysis tells you how fast something is happening, but only in a sample you've already made. Quantum analysis tells you why it's happening, all the way down at the level of electrons. And because you know why, you can actually predict the outcome you want. It's literally the difference between measuring the past and designing the future.
Okay, so that's the theory. But what does this actually look like in the real world? Let's break down how this quantum advantage completely turns three sensory experiences, things we can all relate to, totally on their head.
First up, aroma. You know, that powerful first impression. It can literally make or break a product, right? So how do you get it perfect?
Just look at the difference here. It's incredible. The old molecular way, you need a physical sample, you stick it in a machine, and you measure how gas comes off it over time. The quantum way, you don't need a sample at all. It just digitally calculates the vapor pressure directly from a molecule structure, predicting the smell before it even physically exists.
And that is the whole point. Just think about how powerful that is. You're not just mixing things together and hoping for the best scent. You are digitally engineering it right from square one. All right, next up, taste. And we're tackling a huge challenge in both food and pharma: suppressing bitterness. So the old way, it's slow, and honestly, it's pretty subjective. You're using an electronic tongue, or even slower, a panel of actual human tasters with stopwatches, just trying to see how fast a bitter taste fades away. The quantum way, though, it's totally objective and incredibly precise. It simulates exactly how that bitter molecule latches onto a taste receptor on your tongue, and it calculates the energy of that specific interaction.
So what does that mean? It means you can stop guessing. You're no longer just throwing ingredients at the problem, hoping something will mask the bitterness. Instead, you can use a computer to design the perfect molecule to block that receptor. You're engineering the taste experience at its source. It's precision versus plain old guesswork.
And for our last example, let's talk about mouthfeel. You know, that really critical, often overlooked part of the experience? The texture. It's what often separates a regular product from a premium one.
Okay, so the old molecular approach uses this machine, a rheometer, to measure a bulk property. Basically, how a liquid thins out when you, say, swallow it. But the quantum approach, it goes so much deeper. It models the actual forces between the molecules, those tiny hydrogen bonds and van der Waals forces, that are creating that viscosity in the first place.
So you're not just mixing stuff anymore to see what kind of texture you end up with. No, you are literally designing the interactions between the molecules to build the exact silkiness or creaminess or whatever you want right from the ground up. All that trial and error? Gone. So we've seen the science, which is pretty cool, right? But what does this all mean for a business? What's the bottom line impact of this massive leap in technology?
This table really sums it all up nicely. In every single one of these cases, we move from just measuring a physical property to predicting and designing its root cause. This isn't just an improvement, it's a total paradigm shift.
Okay, now look at this. This chart, this shows what might be the most staggering advantage of all: pure speed. A typical product development cycle, filled with all that physical testing, can take months. The quantum approach, we're talking hours.
Yeah,
Just let that sink in for a second. 6 months. That's the reality for your competition. Half a year of messing around with physical tests just to get one formulation right. And now, here's the new reality. 72 hours. We've gone from 6 months of guesswork to 3 days of certainty. I mean, the implications for how fast you can get to market are they're absolutely enormous. So when you add it all up, what are you really getting? You're getting this, a 24-month head start, a 2-year competitive advantage. Because while everyone else is still stuck in the lab measuring things, you're already out there launching the perfect product.
And this really brings us to the most important takeaway. Quantum isn't just a better way to measure things. It's a completely different activity. It lets you design perfection from the start. And those old molecular methods, well, they just become a final check at the end, a way to confirm what you already knew was perfect.
And so, that leaves us with just one final thought. The technology to completely leapfrog your competition, it exists right now. So while everyone else is busy measuring the past, the only real question is, why aren't you designing the future?